Afternoon, everyone. Originally, this talk was going to be given by Sadaf Alam, but unfortunately, she had a small accident at the weekend. She's fine, but she's had advice not to travel for a couple of weeks while she heals up. So she sends her apologies, and you've got me instead. But I'm going to talk about Isambard-AI. This is something you may have just started to hear about a few weeks back, and you'll be hearing a bit more about it soon. And I'm going to tell you everything I can. But first of all, a little bit of history. We've been running Isambard HPC services actually since 2016. So we've been going for a little while, but we've been running at the tier 2 level in the UK, which is the regional level, and there's lots of tier 2 HPC sites. Isambard 1, actually the thing that we've been doing with it is building ARM-based supercomputers, and Isambard 1 was actually the first production ARM-based HPC service in the world. So there had been a couple of prototypes and test beds, but no one had actually run an ARM-based system as a production service anywhere. So we did that back in spring 2018, quite a long time ago now. And that actually worked better than we'd hoped. So we expanded that system with some follow-on funding in 2020 and ended up building a 21,000 core system. That's a picture of the machine once it had been upgraded, actually at the Met Office in Exeter. So the Met Office has been looking after Isambard for us up to now. Because this was a slightly weird machine, it was ARM, not x86, which is what everyone's used to. We thought we might get 50 users or 100 users or something like that. We're now actually getting quite close to 900 registered users on this system, which kind of amazed us. And it's because in the end, it turned out to be very easy to use. It's like anything else, which is kind of what we hoped, but we didn't know that's what it was actually going to be like in the beginning. So most people just use it like any other supercomputer. The fact that it's ARM hasn't really mattered. And that's great. That's what we hope will be the case. So far for these systems, we've had nearly £8 million of funding. And like I say, we've had a very nice relationship with the Met Office in Exeter. And we've run this as a Great Western 4, a GW4 project. So that's the universities of Bath, Bristol, Cardiff and Exeter, all in the southwest of the UK. And that's all been going very well. We've had various awards and so on. I've listed a few achievements here of things that we've done so far. Actually delivered nearly 1 billion core hours so far, all on ARM, which even though it's quite a modest sized system, because we've been running so long, we've actually delivered quite a lot of compute power. It's about 20 million core hours a month. But in that time, possibly more significantly, we've had hundreds of different scientists and engineers training on the system, not AI training themselves, getting their software working and optimized and ported across to ARM, and that's actually going to turn out to be quite a useful thing in the near future. We've run loads and loads of hands-on tutorials, actually giving people access to the machine. We run the system in a very open access way. So we've run lots of hands-on tutorials and hackathons at various conferences, at Supercomputing, ISC, the ARM HPC user group, and lots of others. And there are lots of codes that you use which probably were ported to ARM for the first time using Isambard. So at our very first hackathon, for example, we had the GROMACS developers. We've had GROMACS mentioned today already. So that was the first time it was ported to a real ARM-based HPC system. The Met Office did their port of the unified model across to ARM using Isambard. VASP was first ported across, and so on and so on. Lots of codes that you're familiar with. OpenFOAM is another good one that's ported to ARM first on Isambard. And that's led to lots of other cool stuff. We won a Best Paper Award for the work at the Cray User Group in 2019. We had lots of first time people have had access to ARM technology at various conferences. And we've also given back lots of improvements in the software ecosystem for ARM. As all this work's been going on, when we find bugs or things missing in the math libraries, all of that goes back into the ecosystem and the quality's really improved over time. So we're very pleased with what's been going on. And of course, as with most systems, over time we've kept track of how busy the system is. Here's a utilization graph. Generally the system is very full, so it's full, just doing lots of work, doing lots of science all the time, all running on ARM. We've tracked who's been using the system between all the different partners over time. And we've also created quite a lot of press and PR over time as well. So because lots of the first time people actually trying ARM was using Isambard, we ended up with loads of articles in Scientific Computing World and on the top 500 and the next platform, and so on. So that's been fun. I mentioned things like hackathons. We found these have been really productive in the past. These are actually run at the Cray, now HP offices in Bristol. And we've done lots of these, and they've always been very popular and very, very successful. This is something we plan on continue doing. And so far, across all those different events, we've had over 1,000 people attend and try things out. So that for us is one of the biggest sort of impacts that we've been having, is on the people side of things and giving people a chance to try these sorts of new technologies for real. Now, because of COVID, it was a long time before I actually got to see Isambard in person. But last year, I actually finally got to go and see it. So there's me, finally at the Met Office with the system. So there's me and Isambard. So that was nice. And there are other parts of the system as well. So we have racks that have all the storage. We've also included, it's always been very important to us to enable properly scientifically rigorous comparisons between whatever ARM architecture we were using and whatever the rest of the state of the art was. So in some of these racks, we've had something we called the multi-architecture comparison system. We basically had a few nodes of everything else. So all the latest Intel and AMD, including GPUs and CPUs. So that you could really try, okay, well, how well does ARM really do compared to the latest and greatest from everyone else? And that's always been very useful too. So we're going to keep this going through all the way into Isambard-AI. I'll say a bit more about that in a few minutes. We included an A64FX rack in our last upgrade. So this is the same technology that was used to build Fugaku. So that was the fastest supercomputer in the world for a couple of years. Big ARM-based system, about 400 and something petaflops at Riken in Japan. So this was just one rack of that technology. We got an artist to do us a little sort of Japanese-style Isambard visiting Mount Fuji. He never actually went to Japan, as far as we can tell, but artist impression that he was there. So this was 72 nodes of A64FX, which was 3,456 cores. I thought that was a very nice number, 3,456. Purely coincidental. And that's been very interesting to try as well, because A64FX was the first shipping ARM processor that supported their new wide vectors, these fast vectors. So it was good to get our hands on that. So that's sort of where we are today, and we're currently running Isambard 2 still right now, and it's still full, doing lots of great stuff. But we have Isambard 3 coming real soon now, and this is quite a big shift for us. So actually, it's significantly more funding than we've had before. So it's just over £9 million of capital and £6 million to run the service for 4 years. So that's a lot more money than we've had in the past. And this is going to be an NVIDIA Grace-based system. So many of you will know NVIDIA is starting to develop their own CPUs. I did say CPU with a C, not a GPU with a G. And there's lots of reasons why they're doing this, and they're using ARM. So we are intercepting these new ARM-based, very fast, very powerful CPUs from NVIDIA, and we're building the new Isambard based on Grace. So these are the Grace systems. It's going to be one of the first in the world using this. There are going to be a few others dotted around in the US and Europe, but Isambard 3 will be one of the very first. It's a much bigger system. It's over 55,000 cores, somewhere between 2 and 3 petaflops, all just from CPUs. So that's all kind of easy to use, general purpose, fast CPU performance. And nicely, going back to energy efficiency, the system in terms of both flops and memory bandwidth is over 6 times faster than the current system, so 6 times faster than Isambard 2, while using slightly less power. So it's significantly more energy efficient. It's over 6 times more energy efficient than the systems we're going to replace. Of course, lots of things have moved on in the years since we built Isambard 2. We're going to be using lots more liquid cooling than we've ever used before. And that really helps in terms of energy efficiency, but also gives us some potential in terms of energy reuse. And we have a follow-on project that's going to join up with Isambard-3 to actually use the warm water that's going to come out and use it to heat the building next door, which is something we have not done before. So the building next door is a university building, the National Composite Centre, great big warehouse-style building, lots of big experiments inside, lots of big bits of equipment. They do things like bake aircraft wings. This is a giant building. So they use quite a lot of energy to heat that in the winter, and we're now going to be able to give them a few hundred kilowatts of nice warm water. So rather than us venting this, which is what we would have done in the past, we're going to be able to reuse that. That will reduce our overall carbon emissions of these two things together. So we're hoping to be able to do much more of that in the future. A few quick tech specs. So each node's going to have 144 cores. That's a lot of cores. Isambard-2's got 64 cores per node. These are really fast cores too. These are not kind of lightweight. These are very fast, meaty cores. They're sort of similar to an Apple M1 style core, 8-way superscalar, for those of you who know computer architecture. So these are really heavyweight. They have very good single thread performance and lots of memory bandwidth, a terabyte a second of memory bandwidth per node to 256 gigabytes of memory. So these are going to be really good, very fast nodes. The other nice thing that'll be new for us is now our technology is coming from NVIDIA. We're going to get lots of NVIDIA software stack that we've never had on Isambard before, including some of their libraries for AI and machine learning. So that will be very interesting to see how that gets adopted in the near future. This is going to happen very soon, and it's happening in a modular data center, which is also something we have not done before. So in other words, think shipping container, but purpose-built for putting a supercomputer inside. It comes on a big truck, and then the system gets built inside it, and it goes in a car park. We then have to put it in like a compound, so it gets a fence and things like that. But we don't have to build a building, so we don't have to go through all of that trouble. You can go inside one of these really nice sort of modular data center shipping container type things. The site's about to start being prepared for that, so we start that in early November, and that should be mostly done by the end of the year. So that's how quickly these things can happen. So these modular data centers have some very nice advantages in terms of how agile you can be, how quickly you can develop some new sites. So we're very excited by this. We're very excited by the Grace superchip. We think they're going to be really fast. In fact, we're hoping to very quickly produce some benchmark results. And I think we'll see a lot of other people going, hang on a minute, this looks really good. Why aren't we looking at this as well? So I think we've got some really nice competition at last for x86 and for Intel and AMD on the CPU front. So watch this space. I mentioned the National Composite Centre. This is where Isambard's going to be in the future. The Met Office unfortunately can't host for us anymore because things have been changing for them. But we managed to find a really nice location in Bristol. We did quite a big search around all the different university facilities to find if there was somewhere that would have enough space and enough power. That was the tough one, actually, the power. But we also had to worry about things like, well, how long is it going to take to get planning permission to actually put these things in? And actually in the middle of the city centre, it takes much longer to get planning permission for things than elsewhere. So the National Composite Centre is part of the university. The nice thing is it's in a science park. Science parks are meant to do this sort of thing, so they have very good, sort of quick and efficient planning permission processes. So this is where we're going to go. Also, the NCC itself, it describes itself as digital first. So in other words, they kind of do all their design and simulation, and then they kind of build something to prove that the process worked. But they do all the design and simulation first before they ever make anything. So these guys actually need lots of simulation too. So they were very happy for us to put a big supercomputer in their car park. So we're going in that little, if you look the top-down view on the right-hand side there, that little rectangle down in the bottom left is where we're going. If we zoom in on that a little bit, the red rectangle, this almost a square, is actually the compound we're going to build for Isambard-3. And the rest of it is space for expansion, which I'll say a bit more about in a moment. The little rectangles are car parking spaces to give you some idea of scale. So we're going to use some of the car park. Of course, the car park doesn't get anything like as full as it used to, because since COVID, many more people are working from home. So the car park's never more than half full. So we can put it to good use. We can put some energy efficient supercomputing in there rather than just more cars. So it's going to look like this. So this is with Isambard next to it for scale. So you can see roughly how big it is. You might need to take his top hat off to get through the door. But otherwise you can see how big they are. So standard shipping container, about 40 feet long, 12.5 feet high, just to give you some idea. The boxes behind are the cooling, so there is cooling outside. It's mostly free cooling, so we will have chillers, but they actually only need to run when you have very hot, sustained periods. Most of the time it's all free air cooling. It's amazing how energy efficient these things have got. So that's what we're doing sort of now, if you like. So I haven't really talked about AI yet, have I? So where does the AI come in? Well, because we'd been doing this and we'd had to find a site with enough space and power and networking, and we'd gone through planning permission and we designed a site, it turned out that was quite convenient for doing something else and maybe building a big AI supercomputer. And we started hearing about this earlier in the year, didn't we? Back in March, I think it was, when the government announced they really wanted to fund a national AI research resource. And that was because there's so much going on in the UK in AI research, but we just didn't have enough compute power to support it. If you wanted to train a large language model and you needed a few hundred GPUs or 1,000 GPUs for several weeks, forget it. It was just completely impossible. We've got a few GPU systems around the UK. They've all got a few hundred GPUs each. You couldn't really soak up all of one of those for yourself for weeks at a time because everyone else needed to use it. So many people have been telling the government we're kind of starved in terms of capability. We need to do something about this desperately. So back in March, the government said, right, we're going to find some serious funding. We're going to try and make this happen. And the search started to find out where this could go. Of course, we'd started doing Isambard-AI by then. And if you look through recent things that have come out in the last year or so in terms of the Future of Compute report and other things that have come out saying, what do we need? There are a couple of common themes that came out, and I've listed a few here on the slide. So the AI research resource, so the AIR, needs to be able to support a number of different initiatives. There's this big drive towards AI safety, which the government's very keen on. We need to support that. There's a whole load of foundational model work, which we need to be able to support. There's a frontier task force and an AI task force who need access to a resource. So whatever we design, we need to make sure we can support those groups. We're not just looking at academia either, but academia and industry and the public sector in terms of users for this system in the long term. We need to be able to support lots of different scales of AI research. So not just small scale, but very large scale, thousands of GPUs all working on something at the same time. Can we support that? We need to be able to support not just AI training, but also AI inference and hybrid workflows. So not just AI, we're not just going to be training large language models, but what about people who want to actually use AI to steer their simulations or use simulation as an input to AI and training? So hybrid workflows was also very important. That was quite an important requirement actually, because if you were just going to be training large language models, there are other options for how you might do that. There are things that can do that very well, but can't do other things. So the fact that we wanted something that was going to be flexible and agile and would also be able to keep evolving over time. The way people train large language models today is not how it was being done 2 years ago. And in 2 years' time, who knows how that will have changed again. So we needed something that was going to be quite flexible, that was going to be able to keep evolving over time. And also, I put it last on the slide, but energy efficiency is a key consideration. Any one of these resources is going to be quite energy intense. It's going to use lots of power. So if we're going to do that, we need to make it as energy efficient as possible, and we really need to find ways of, if it's going to generate waste heat, how can we reuse that to offset all of our own carbon emissions? And of course, the university, like many of our universities, has its own net zero by 2030 target. So we had to take that very, very seriously. So what did we do with all of this? Well, we thought, okay, well, if people are going to use an AI research resource, We can't just build it like a traditional supercomputer, because most of the users who come to it won't know how to deal with that. What's SSH? What's a terminal? Many of our users won't use a system like that at all. So we needed to think about, okay, this system's going to be accessed in much more of a cloud-style mode. People want to use Jupyter notebooks, just fire it off onto hundreds or thousands of GPUs. Why should they care? Of course, we'll support all the traditional sort of HPC styles of access, but actually, why not support all these other modes too? That's what will help people be productive. The other thing is the AI research resource, that there are going to be several systems within that community, not just Isambard-AI. So we want to make sure all of those are fully joined up. We call it federated. So there's something more we'll say about that quite soon too. And within one resource, we want to support real multi-tenancy. So in the past, traditional supercomputers, actually they were very hard to chop up into pieces. They were very brittle to that sort of change. It might involve fairly serious surgery on the whole software stack, which is very intrusive. Whereas of course in the cloud, you're very used to saying, actually I want my own system, and it gets set up and it's all kind of independent. Why can't we do that for the sorts of stuff that we all do? Well, it turns out now you can. You just need to be careful in how you architect the system, especially around the storage. The storage is often the bit that's a bit more tricky to make really multi-tenant, where you can in software carve off chunks of the system and say this part is yours. You won't be able to see anything outside of your partition and no one will know that you're there. So that can be very useful depending on the sorts of research that people are doing. So we're designing things in a much more of a multi-tenant aware style. We could not do that in the past. We couldn't have done this on Isambard 2. It just wasn't possible. We want to support lots of different scales of research. So if somebody wants 1 GPU, fine. If you want 1,000 GPUs, we can do that. Right? And today that is just not possible. And the storage turns out to also be very, very important. And in fact, the storage side of this is probably where Isambard-AI is more different from a traditional HPC system than in other aspects. So there are different parts of the storage solution for it, some of which are optimized for very high IOPS, and lots of small file accesses, which is the sort of thing that happens in AI type workflows. And that maybe you don't get quite so much in a traditional HPC type workflow. But you do have traditional HPC style file access too, especially if you're going to be supporting hybrid type workflows. So actually you need both those styles. So maybe you need a storage solution that actually can support both of those types of I/O. You won't be surprised to hear that to deliver a lot of those characteristics, we actually exploit a lot of solid state storage technologies. So this very flashy, intense storage solution. And we'll be able to say a bit more about that soon. I'm not going into too many specifics. Notice I haven't said who the vendor is or exactly what GPUs we're using. And that's because there's the AI Safety Summit coming up soon, and the plan is to announce more detail there. So I've got to keep some of the details under the hat for now, but we'll be able to tell you very soon what it all is. So we're very excited about the storage architecture in this system. And then in general, it's been designed to support training, including for very large language models, but also inference and hybrid workflows, and to be able to cope as all of this changes in the future. So we're designing it to be very flexible. So that's what Isambard-AI is going to be. So we know this is going to happen. We've got the funding for it. We've run a procurement. We've selected a vendor. They know it's them. And everything should be announced in a couple of weeks at the start of November. So we can then be much more open about it. But the things that have already been said, it's based on the latest generation of GPUs. It's going to be over 5,000 GPUs. We're finally going to have a really serious, meaty GPU resource in the UK. Has a large, very fast, very clever storage system that makes very heavy use of flash. The software stack is very much optimized for AI workflows and cloud style usage, and it's much more, it's probably the biggest difference between Isambard-AI and all of the other services we've delivered so far. And it comes in at under 5 megawatts, and 5 megawatts is a lot of power. But the fact that we had 5 megawatts was one of the big differentiating factors for doing this. We make very heavy use of direct liquid cooling. So the main system, there are no fans in it, which is amazing. No fans at all, so all direct liquid cooling. So we'll get pretty much all of the waste energy back out as hot water, and then we can do some interesting things with that. So like I said, with Isambard-AI, we're already going to be using its warm water to heat the building next door. So we're going to have a lot more hot water that we can put to good use in the region very soon. So we don't know exactly what it's going to look like yet, but it's going to look a bit like this. So it's a bit bigger. Isambard's still there. I've got a sort of prototype site layout, and it's deliberately a bit hard to see because it's not being announced properly yet. But to put a sort of cartoon on it, on the left is the little sort of square compound for Isambard-AI. And in fact, we have a bit of space inside Isambard-AI. And so what we're going to do is we're going to actually take early delivery of some GPUs early next year, in about March. So in about March, we're going to get something like, I think we can fit 168 of identical GPUs to the main system into Isambard-AI in about March. So as quickly as we can get those up, we'll start making those available, and people can start trying things out in the sort of, well, if it's going in March, maybe it'll be April or something like that. And then on the right-hand side, that's sort of like the first draft of the site for Isambard-AI. It's the big box is where the main thing goes. You notice that's about twice the size. And it's only about twice the size, which is amazing, isn't it? Amazing how dense these things can be. So that's about 2 shipping containers side by side to fit 5,000 GPUs in and 5 megawatts in a car park. And then the other boxes are the cooling and the power distribution and pumps and a tool store and things like that. But in the past, these things would have been gigantic, football fields size, and now we're talking something about the size of 2 shipping containers, and the cooling. It's really remarkable. So of course people get worried about, well, can someone just pick this up and put it on the back of a truck and steal it all? So no, don't worry. It's still pretty big. It's 40 feet by 40 feet. You need a pretty big lorry to do that. But I understand where you might be worried. So Isambard-AI, I mentioned earlier, we're about to start building that part of the site, and that will all be the site's ready by the end of the year, and then the pod actually arrives in January, and then the system all goes in February or March. Isambard-AI plan is to do it next summer, which is pretty damn quick. If we get it done, I think our first phone call about all of this was in August. So if we get it done by next August, we'll have done the whole thing in 12 months. And we've got a reasonable shot of doing that. So, just a quick summary for you all. So we've got next generation, flexible and very sort of user-oriented AI services coming. They're optimized for large language model development, but not just the training side, also inference and hybrid workflows. We're very passionate about hybrid workflows. We think that might be where some of the really exciting breakthroughs come from, when people start joining up simulations and different sorts of AI techniques. It's going to be over 5,000 of the latest generation GPUs, and we'll be able to tell you which ones and who they're from real soon now. There's some very clever storage architecture, which we're very excited about. We'll have true multi-tenancy support, which I think is actually a really important part of this whole solution. The whole thing's been designed so that the software environment can evolve over time. We found with our traditional systems in the past, that's been a real Achilles heel. The whole thing's been very sort of monolithic software stacks, and you kind of have to do these big bang upgrades of everything, which affects everyone. And now, I think largely thanks to all of the developments that have been going on in the cloud, it's much easier to give people customized, very containerized style environments, which you can then set up as you want for your needs. And then as things happen in the rest of the system, it doesn't mess you up. And vice versa, you don't mess up what other people do with whatever you need for your own local environment. So I think this is one of the nice ways things have really improved more recently. The whole system is designed to be incredibly energy efficient. So actually, I didn't say, for Isambard-AI, the energy efficiency of that CPU-based system, the NVIDIA Grace CPU-based system, should be amongst the best that's ever been achieved for a CPU-based system. So it'll be one of the most energy efficient machines ever been built. And that goes even more so for Isambard-AI. So we're very excited about that. And the whole point of doing this, why do we care? We want to enable next generation science. I guess it's AI-enabled science. That includes the science of AI itself. But that's the reason we do all of these things, right? That's what we actually care about. We're not building it for its own sake. We're doing this to enable amazing new things, some of which we haven't even thought of yet. So it'll be exciting to see what happens. So with that, I will stop there, and hopefully we will have time for a few questions. Thank you very much.